Hi all, welcome to new class. Today's class is about the problems on torque voltage analogy and torque current analogy. So if you didn't watch the class about the torque voltage and torque current analogy, please go through it. So let us do the problems. First one, write the differential equations governing the mechanical rotation system shown in figure. Draw the torque voltage and torque current electrical analogous circuits and verify by writing mesh and node equations. So this is the given mechanical rotational system. So there are two nodes J1 and J2. So first of all we have to find the free body diagram, that is we have to draw the free body diagrams. So there will be two free body diagrams since there are two nodes, and after that we have to write the differential equations. So first of all draw the free body diagram of this node J1, free body diagram, that is for J1. So T is the applied torque. Then let theta 1 and theta 2 be the angular displacement, and also omega 1 and omega 2 be the angular velocities. Then here the angular displacement is theta 1. Then the opposing torques are due to this J1, that is due to this moment of inertia J1, Tj1. Then due to this B1, Tb1. Then due to this K1, that is Tk1. So these are the opposing torques. Then by Newton's second law we can write this Tj1 plus Tb1 plus Tk1 is equal to the applied torque T. Now we can write Tj1 is J1 into d square theta 1 divided by dt square plus Tb1 is b1 into d theta 1 by dt plus Tk1 is k1 into this k1 is in contact with both J1 and J2, so we have to write theta 1 minus theta 2, and that is equal to T. Now we have d square theta divided by dt square is equal to d omega by dt, and d theta by dt is omega, and also theta is equal to integral omega dt. So this equation we can write J1 into d omega 1 divided by dt, then plus b1 into d b1 into omega 1, then plus k1 into integral omega 1 minus omega 2 into dt is equal to t. So this is equation 1. Now for this J2 we have to draw the free body diagram. So for J2, angular displacement is theta 2. Then opposing torques are due to this J2, that is Tj2, then due to B2, that is Tb2, then due to this K2 and K1. So TK1 and TK2. So these are the opposing torques, and theta 2 is the angular displacement. Now by Newton's second law, we can write J Tj2 plus Tb2 plus Tk1 plus Tk2 equal to 0, and Tj2 is J2 into d square theta 2 divided by dt square plus Tb2 is b2 into d theta 2 divided by dt plus Tk1 is k1 into theta 2 minus theta 1, because k1 is in contact with both j1 and j2, then plus Tk2 is k2 into theta 2, and that is equal to 0. Then d square theta 2 by dt square is d omega by dt, so we can write j2 into d omega 2 divided by dt plus b2 into omega 2 plus k1 into integral omega 2 minus omega 1 dt plus k2 into integral omega 2 dt equal to 0. So this is equation 2. Now to draw the torque voltage analogous circuit, we have to consider T. The torque is analogous to the voltage source, then omega 1 angular velocity is analogous to the current I1, then omega 2 I2, then J1 is analogous to L1, then J2 analogous to L2, then B1 is analogous to R1, B2 is analogous to R2, then K1 is analogous to 1 by C1, then K2 is analogous to 1 by C2. So these two equations we can write. First equation is J1 into d omega 1 by dt, that we can write J1 into d omega 1 by dt. So we can write L1 d I1 divided by dt plus B1 into omega 1, we can write R1 into I1 plus this K1 into integral omega 1 minus omega 2 dt, we can write 1 by C1 integral I1 minus I2 dt equal to this T is analogous to E of T. So this is equation number 3. Now this second equation we can write J2 d omega 2 by dt. So we can write L2 into d I2 divided by dt plus R2 into I2 plus here 1 by C1 integral I2 minus I1 dt plus this K2 is 1 by C2 integral I2 dt, and that is equal to 0. So this is equation number 4. So here the common element is this capacitor, and there will be two closed loops. So we can draw the torque voltage analogous circuit. So there is the voltage source, then L1, then R1, then the common element C1, then in the second closed loop there will be L2, then R2, then C2, then the current is I1 and I2. So this is the torque voltage analogous circuit. Now we have to draw the torque current analogous circuit. So for that, in torque current analogous circuit, torque is analogous to the current source. Then B1 is analogous to 1 by R1, B2 is analogous to 1 by R2, then omega 1 is analogous to V1, omega 2 is analogous to V2, that is voltage. Then J1 is analogous to C1, J2 is analogous to C2, then K1 is analogous to 1 by L1, K2 is analogous to 1 by L2. And equation 1 and 2 we can write, that is C1 into dV1 by dt plus 1 by R1 V1 plus 1 by L1 integral V1 minus V2 into dt equal to I of t. So this is equation number 5. Then the second equation we can write C2 dV2 by dt plus 1 by R2 into V2 plus 1 by L1 integral V2 minus V1 dt plus 1 by L2 integral V2 dt equal to 0. So according to these two equations we can draw the circuit. So here L1 is the common element and all the elements are parallel. So I of t, then C1 and R1. So C1, then R1, then L1. L1 is the common element. Then in the second equation C2, R2, then L2. So C2, R2, then L2. So these are the elements and V1 and V2 are the two nodes. So this is the torque current analogous circuit. Let us do another problem. Write the differential equations governing the mechanical rotation system shown in figure. Draw the torque voltage and torque current electrical analogous circuits and verify by writing mesh and node equations. So this is the given figure. So there will be three nodes, that is J1, J2 and J3. So we have to draw the three free body diagrams and their differential equations. Let theta 1, theta 2 and theta 3 be the three angular displacement and omega 1, omega 2 and omega 3 be the angular velocities of these three nodes J1, J2 and J3. So let us draw the free body diagram of J1. So for J1 the applied torque is T, then angular displacement theta 1. Opposing torques are due to J1, K1 and B1. So T J1, T B1, then T K1. Now by Newton's second law we can write T J1 plus T B1 plus T K1 equal to T. Tj1 is J1 into d square theta 1 by dt square plus B1 into, this B1 is in contact with both J1 and J2, so we can write d by dt of theta 1 minus theta 2, then plus this K1 is also in contact with both J1 and J2, so K1 into theta 1 minus theta 2 equal to T. And d square theta by dt square is d omega by dt. So we can write J1 d omega 1 by dt plus B1 into omega 1 minus omega 2 plus K1 into integral omega 1 minus omega 2 dt equal to T. So this is equation 1. Now we can draw the free body diagram of J2. So J2 is in contact with K1, B1, B2, etc. J2, then angular displacement is theta 2, then T J2, T B2, T K1, then T B1. Now by Newton's second law we can write T J2 plus T B2 plus T K1 plus T B1 equal to 0. Tj2 is J2 into d square theta 2 divided by dt square, then plus B2 into d by dt of theta 2 minus theta 3, then plus B1 into d by dt of theta 2 minus theta 1 plus K1 into theta 2 minus theta 1 equal to 0. And here we can write J2 into d omega 2 divided by dt plus B2 into omega 2 minus omega 3 then plus B1 into omega 2 minus omega 1 plus K1 integral omega 2 minus omega 1 then dt equal to 0. So this is equation 2. Now we can draw the free body diagram of J3. So for J3, angular displacement is theta 3, then opposing torques are Tj3, then Tb2, then Tk3. So by Newton's second law we can write Tj3 plus Tb2 plus Tk3 equal to 0, that is J3 d square theta 3 divided by dt square, then plus B2 into d by dt of theta 3 minus theta 2, then plus K3 into theta 3 equal to 0. And here we can write J3 into d omega 3 divided by dt plus B2 into omega 3 minus omega 2, then plus K3 into integral omega 3 dt equal to 0. So this is equation number 3. Now we can draw the torque voltage analogous circuit. So for that we have to consider the torque is analogous to E of t, then omega 1 is analogous to I1, omega 2 I2, then omega 3 I3, that is the current. Then J1 is analogous to L1, J2 L2, then J3 L3, then B1. B1 is analogous to R1, B2 is analogous to R2, then K1 is analogous to 1 by C1 and K2 is analogous to 1 by C2. Since there are three differential equations, so there will be three closed loops in torque voltage analogous circuit. And here, so here in the first case K1 and B1 are common. So K1 is analogous to the capacitor and B1 resistor. So capacitor and resistor will be common in the first loop. Then second loop there will be the resistance in common. So in the first equation there will be J1. J1 is inductor. Then B1 is analogous to resistor. K1 is analogous to capacitor. So these two are common elements, and the other two elements are J1 and T. That is, J1 is inductor and T is the voltage source. So let us draw, that is the voltage source E of t, then inductor L1, then common elements are C1 and then the resistor R1. So this is the first loop. Then for the second loop there will be J2. J2 is L2, then B2, that is R2, then and this R2 is common element, then there will be B1 and K1. So these two are common elements that we have already drawn. So here we have to draw this L2 and common R2. Then in the third loop there will be J3. J3 is L3, then B2. B2 already we have drawn. Then K3. K3 is C3. Sorry, this is K3, that is C3. So here L3 is there, then C3 is there. So this is the torque voltage analogous circuit, and this is I1, this is I2, and this is I3. Next we have to draw the torque current analogous circuit. So for that we have to consider torque is analogous to current source, then omega 1 V1, that is voltage, omega 2 V2, then omega 3 V3, then J1 is analogous to C1, then J2 C2, then J3 C3, then B is analogous to 1 by R1 B1, then B2 is analogous to 1 by R2, then K1 is analogous to 1 by L1, K3 is analogous to 1 by L3. Now we can draw the circuit. So here first of all we have to draw the current source, that is I of t. Then in the first equation J1 is there. J1 is analogous to capacitor C1, that is parallel. Here the all elements are parallel and the common elements are R1 and L1. R1 and L1. Then in the second one there is C2, then R2 is common, then C3 and L3 are there. So this is the torque current analogous circuit, and this is V1 and this is V2, then this is V3. So this is about the problems related to torque voltage analogous circuit and torque current analogous circuit. So thank you for watching the class. If you like the classes, please like, share and subscribe my channel.